make it tall, stick it under my wall, and make it a prefab. Okay, so I've got a wall that I can use. And now that it's a prefab, I don't need it here anymore in the scene. I'm going to generate them automatically. Okay, second thing I want to do, let's make Game Manager. There was that tutorial I sent out. Did anybody get a chance to read through that tutorial? There was some good things in that tutorial. There was some stuff that I thought was just too different. You could go into. It's hard to read a tutorial online. He does a good job trying to explain it, but it's hard to actually know where you type what. He highlights things in yellow. Kind of hard to read sometimes, but you can learn a lot from that tutorial about how things work, but not really struggling with how do I do something slightly different. That's the whole point of what I want you to do. So let's work through this. Here's a game manager. It does what it does, which is nothing right now, but I want a script. Let's make a C# script called Game Manager script. Let's shrink this down. I want them to look like that. Perfect. Okay, so MonoDevelop. Let's go open up my game manager. Here's my script. It has nothing, but this is already subclassed to MonoBehavior, which is really convenient. All the components, all the things that we add to objects are going to be MonoBehaviors. There might be other things you want to subscript, but the most common thing that comes together is MonoBehavior. We already are importing this library Unity engine. We're already importing the system collections if we need them. So those are going to be there. We've got this start, and we've got this update, and we've got the place to add some fields. So I want public game object wall, public integer size in the x direction, public integer size in the z direction. Okay, let's start attaching this to an object, and I can start seeing pieces come together. I want my wall to be there, and let's make my size, just to be nice here, a 10 by 10 maze. So, back to the script. Let's create a maze. We might want to do other things inside start, but this is the create maze part. Okay, so to make the maze, a couple pieces are going to have to come together. Make the walls for the outer box. Make the interior walls, and make the floor. Those are my steps to put that together. Okay, how can I make some walls for the outer box? Let's do the dimensions of the square. Yes. And I am going to draw them line by line because it's going to help me later. The whole point of my algorithm that I'm doing is take a box and draw lines. So I'm going to think, how do I actually draw a line from some point to some other point? Let's do it hard-coded first and then generalize. So for int I equals 0, I less than size x, I plus plus, instantiate a wall. Where do I want it to go? At a new position, a new vector 3. Let's say at spot this is for size X. So this is going to be I, 0, 0. And then I need a rotation, quaternion identity. Don't forget, gotta close my loop. Whoa, don't like that. Control Z helps me in MonoDevelop actually make the code look like what I want to instead of tab it back all the time. And let's see if that made a line for us. Kind of. What's mixed up? Rotation, orientation. So I can't just say to do the identity, I need to use those Euler angles. And let's rotate it 90 and see what that does for us. So that should take the object, what it was, give it a 90 rotation, and we should be good. Okay, so I need to do that 4 times. To size Z. Let's do it in the I direction. This time it's going to be a bunch of zeros. But I want another one for X, another one for Z. And where should I start them? See if that gives me my outer box. It does. I forgot the rotation of one of them. That looks better. But not perfect. What's missing? The edges and the corners aren't lining up. Why is that?
Because the position's the center.
Yes, the center is where it goes. And inside this wall, it's put at 0, 0, 0 for its position, at 0, 0, 0. So it has a piece of wall on either side of that point. So that's why they're crossed up here, and they're missing down here. So we're going to have to split them off and shift them depending on which direction they're rotated. When it's rotated going this way, we want to shift it back a little bit this way. When it's rotated that way, we want to shift it back in the other direction. So we're going to have to divide them by a half each time and put that together. Okay, so I don't want to keep copying and pasting this in there. I want to start making a general method to make a wall. And now it's a couple leaps to get there from here to what I'm going to write, but I want to show you what I'm going to write and then talk through all the pieces. Because this was hard-coded specifically for these 4 walls. I'm going to try to make it general and then make it even more general so I can draw a wall from any point to pretty much any other point as I try to do my recursive division. So I'm going to make that leap just in the interest of time, but then I'll try to walk through all the pieces that I put together to say, how do I do this in terms of that? So here's what we need to do. I need an X, I need a Z, I need a count, I need to know if it's horizontal or vertical. Okay, so let's give myself equals 0 and vertical equals 1. Give myself some nice constants. Those are going to be put in here for horizontal or vertical. Okay. So instead of going from beginning until size x, 0 to size z, I'm going to go from 0 to count. If I want this wall to be 17 pieces long, or if I want it to be 3 pieces long, that comes in there as count. And then let's do my instantiate, make my wall, vector 3. Oh, I didn't add that piece yet. I plus x minus 1 minus h for v 0.5 f 0 1 minus h over v plus z minus h over v 5f. That one closes. Which one? I lost my parentheses here. Yes. Much better. Quaternion, Euler, 0, 0. Okay. What's going on in that crazy code? This was the result of a lot of abstraction that I did, 3 or 4 levels, trying to say, how do I do this in general? So I need to know if I'm going horizontal or vertical. If I'm going horizontal, then the I gets incremented to my x. If I'm going vertical, 1 minus horizontal says, oh, this one's now active, so the I gets incremented to my z. So it alternates between those two, depending on if this is a 1 or a 0 coming in. It also needs to know which one do I shift. If I'm going horizontal, then I don't shift it in the x direction, I shift it in the z direction, opposite for the other one, and I need to shift it 0.5 away from where it needed to go. And then my orientation needs to change depending on horizontal or vertical, multiplying it times 90 for that twist. This should be the general method I need to replace all of this stuff. And I should be able to replace it with make wall 0, 0, size x, vertical 0, size z, size x. Let's see if those two work. If they do, then I'll make sure the rest of them, compiler errors. I made some syntax problems. You might see this too. Where does it show up?
It's on your quaternion spell it wrong.
Probably, where does the error show up? When I hit this, it says, hey, compiler, there's something wrong.
It's down there.
In the console, yes. So make sure you're looking at the console. The name quaternion doesn't exist. I misspelled quaternion. Yes, now it is blue instead of green. You save it, your errors go away. It says, hey, this was a field that was never used. It gives you warnings. Warnings are warnings. You can make your code work with warnings. You want to get rid of them eventually, but let's see if we got our lines. So here's our 2 lines. Perfect. Our code in general drew them. Let's see if I can get the other boxes to work. Make wall from 0, 0, size z, horizontal, horizontal. Okay, now we're back where we started. It fixed the